Welcome to Module 1, Lesson 7. We're going to go ahead and jump into the lesson. Today we're going to be focusing on the commutativity. I almost always say commutativity. There's no in there. Commutativity of multiplication in array models. So array models, we're going to be hitting on that again, and we're going to also talk about commutativity of it. I struggle with that word, so bear with me. So going off what an array is again, is the idea that you are creating a multiplication sentence visually. So, to give an example of this, I could write a 4 times 2 equals, and we can do that math to find out 8. Once again, I'm not focusing too much on the answer yet, because that's not what the main focus of this lesson is about. It's about being able to take an image and represent it and look at it in a different manner. So, I'll make this an array. Once again, as a reminder, the 4 at the very beginning means how many groups we have, times 2, and they're saying there's 2 in each group. So there's 4 groups of 2. So go ahead and make those 4 groups, 1, 2, 3, 4, and there's 2 in each group. So 1, 2, 3, 4, 5, 6, 8. So 2 in each. You get a total of 8. So commutativity, the idea behind it is that there's fluidity in math, multiplication especially. And many of us may already understand or know the idea that 4 times 2 equals 8. And if we know that, that means we should automatically know that 2 times 4 equals 8 as well. 2 groups of 4 equals the exact same thing of 4 groups of 2. Now, I can prove that to you visually. Over here, we have 4 groups of 2. 1, 2, 3, 4, with 2 in each group. Now, I'm not going to change this picture. I'm not going to touch it at all. Well, at least the picture. And I'm going to show you how I can make this picture answer this question. Of course, it still equals 8. But right now, this shows 4 groups of 2. I can make this show 2 groups of 4. Go ahead and watch real quick. If I turn the board sideways, you can now see I have 2 groups with 1, 2, 3, 4 in each one of them. So I could say that there's 2 groups of 4 will equal 8. So in all honesty, this is about the entire lesson that we're going to be talking about. We can go over and we can talk about multiple examples and a whole lot of all those other things, but this is primarily what this lesson will be about. So I'm going to go ahead and flip this back. But I also want to talk about how different methods and different ways you can visualize this. So you can do the 4 times 2 equals 8 or the 2 times 4 equals 8. Another method you could do is you could say there's 4 2's. Once again, it looks a little weird. I agree, it sounds a little weird too. But this is I have 4 2's. There's 4 2's of them. So there's 1 2, 2 2's, 3 2's, 4 2's. 1 2 3 4 2's. Just an interesting way of writing that. And this is equal to that. So I'm going to kind of erase things up here just to visually show you what things are the same. We already know that these two are equal to each other. We visually have shown that. So 4 times 2 equals 8 is the same thing as saying 4 2's equals 8. 2 times 4 is 2 4's equals 8. These two are saying the exact same thing. These two are saying the exact same thing. They might look a little bit different, but once again, it's recognizing when different things are saying the same thing. This could basically be just saying like, I have a 2-pack of Snickers, but I have 4 packs of them. There's 4 groups of 2, so 4 2's. So a total of 8. So kind of going off that same idea. Now, on some of the assignment questions in your problem set, and maybe even on Zern, you will run into a question like this. You'll be given one of these things, and you will need to find what it means in that format, in the opposite format. So let me show you. So let's say I have 3 times 4 right here. 3 times 4. And it tells you to do like give a multiplication sentence or give this form of it. And you would write there are 3 4's there. Or you might have the opposite. You could have a situation where it says 6 threes. And it asks you to write that in the multiplication sentence. And you write 6 times 3. And then you give the answer of 18. So that's kind of the primary of this. This lesson is a lot more practice than teaching it. But I kind of want to hit a couple more things on this, is that in math with multiplication, the factors, and remember the definition of factor, a factor are the numbers in a multiplication, or just any form of math equation. The factors in them, those, are kind of, you can move them around. It doesn't matter if you move those around in multiplication. I'm wanting to specify that. I'm saying multiplication. And I'm going to show you a non-example here. Because I can say, if I know that 5 times 2 equals 10, that means I automatically know that 2 times 5 equals 10. I know that. That's the commutativity property. Bear with me again on this pronunciation of it. And so a non-example would this be in division. If I know that 10 divided by 5 equals 2, that does not mean 5 divided by 10 equals 2. That's not true. It does not work that way. It doesn't. Granted, it does work in kind of a bit of a different way, and I'll show that real quick. I'll use the exact same answer. If I know that 10 divided by 5 equals 2, that means that 10 divided by 2 equals 5. So, not going to have to focus or worry too much about this example right here with division. The main thing you're going to want to focus on is understanding that format and how you can take an array and you turn it sideways. It's giving you the same answer and it's showing the same thing. So right before getting off of this, I'm going ahead and show you just one more example of how it works for here. So I'll make 5 groups of 2. Actually, I'll do a different one because we already did 4 groups of 2. So I want to mix up the numbers just enough, just to kind of help prevent that there's any doubt in that this does work. So let's do 5 and 3. So 5 groups of 3. So 1, 2, 3, 4, 5 with 3 in each. So 1, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3. We can agree this is 1, 2, 3, 4, 5 groups with 1, 2, 3 in each. Now, if I'm correct on this, if I take this board and I turn it, it should be 3 groups of 5. Now, let's double check real quick. We grab the board, we flip it all the way around, and we double check. We have 1, 2, 3 groups with 1, 2, 3, 4, 5 in each group. So it works. And this will work every single time in multiplication. For the first 2 factors, the groups and number in each group, in multiplication, you can always swap those, and those will always give you the exact same answer no matter what. Rules change a little bit in division, but right now we're focusing on multiplication. So the commutativity property is just the main idea that you can swap in groups and you can swap in each groups their meanings, and they'll always give you the same answer. So that's today's lesson, and I hope you guys have a great day.